Good morning, all.
Good morning.
Am I audible?
Yes, sir.
Yesterday we were discussing some problems on this conservation of momentum. And the last problem we were discussing is we are having a truck like this, another truck like this. So this is mass M with this bag. Same case here also, no? Am I right or not? This is the discussion we had, no?
Yes, sir. Yes,
Correct?
Yes, sir.
correct.
Yes.
Right. Then we are throwing one onto the other, no? Yeah, no? Okay. So
Yes, sir.
here if you take this, that means these bags are coming over here. You have seen that onto this, it is receiving a bag from here, and one other bag comes out from like this. At the instant of throwing, this is M2, this is M1. At the instant when they're throwing, both will have velocity of the van only, no? Remember this?
Yes, sir.
Whenever an object leaves another parent object, the object which is leaving the parent has the same velocity as that of the parent. Remember in kinematics, we learned that whenever a body is detached from another body, the detached body has the same velocity as that of the body from which it is detached. A mass falls from a balloon. The mass will be having same velocity as that of the balloon at the instant of throwing or not.
Yes, sir.
Yes, sir.
Remember that?
Yes, sir.
Yes, sir.
So now is the situation. In this situation, what you have here, now the mass of this is how much?
Sir, M plus,
This one.
sir, M minus M1.
It is the mass of this is this. Okay?
Yes, sir.
Because now I am just considering the momentum of this because that is what we are getting now.
Yes,
For
sir.
this
Perfect.
system, our system is this. Now the mass of this is M minus M1. Do you agree with this?
Agrees.
Now afterwards, it falls onto this. So now you will have M2, no? Agreed. And now the mass of this is,
Yes, sir.
okay. Now you have
M
truck
minus M1
mass
square.
plus, do
U
you agree
minus.
with this?
Agree, sir. Agree.
Plus this is coming now.
Yes, sir.
Okay.
Yes, sir.
Clear? System is nothing but only truck of mass. What is the mass of the truck?
M minus.
If I choose the system like this, then I can conserve the momentum, no? Whereby you got this. Remember this?
Yes, sir.
Yes, sir.
Any doubt is there?
No, sir.
No roads.
This is what we have done yesterday. Hope you remember.
Remember, sir.
Clear?
Yes, sir.
Similarly, for the other truck also, you have done the same thing. Now this is into this, it is getting what? M1 is moving with.
Again,
Sir, can you move the page little right, sir? It's not.
And from this,
Okay, sir.
this is going away. What is going away? M2. Now what is coming over here? M1. So that one plus the truck. Now the truck has a mass how much?
sir, M minus M2.
So
Yes,
you
sir.
have this just before at the instant of throwing, it is having a velocity this side you. Okay.
Yes, sir.
Soon after throwing, do you agree with this or not?
Yes, sir.
This is what we learned. Simple conservation of momentum.
Yes,
Any
sir.
doubt is there?
No
No,
roads.
sir.
Clear.
Right. So shall I go ahead? This is what we learned. Just
One,
because the last problem of the class yesterday, I am discussing it once again.
Yes, sir.
Let's turn the
Complete.
page.
Yes, sir.
transcription.
Cricket, sir.
Now let us see an identical one. See, these are the identical buggy. Buggy means bogies. See, they're moving like this. Each one with velocity v naught. Okay. Mass m. Two identical buggies Follow till here.
Yes, sir.
Yes, sir.
Put it down.
Yes, sir.
Hold it still.
Any idea?
Same like as before conversation, sir. But same concept.
See, let the man he did not give anything. No? Here. then at that instant, what is the velocity of the man?
Yeah. Velocity of man with respect to buggy.
With respect to ground,
Uh,
he says that he jumps like this. Man with respect to ground. Agreed?
Agreed, sir.
Agreed.
V1 will come.
Huh?
V1 will come, sir. Or not?
Pardon?
Sir, V1 how it comes, sir? You should write V0 now. Velocity of man with respect to buggy na, sir.
Read that fully, Abrar. Why do you get confused? Before jumping, it is V naught. See, you are
Yes,
not
sir.
reading the whole problem. You are concluding at the beginning only.
Yes, sir, got it.
So here the man jumps. Understood this?
Yes, sir.
Understood, sir. Understood.
Now we have to find momentum. See, when you conserve with respect to what we are taking a loss with respect to ground, no?
So, with respect to ground.
So before jumping, followed this, and
Yes, sir.
immediately after jumping, now as momentum is conserved in the horizontal direction, I can equate this. Get V1. Understood?
Understood, sir.
Yeah, understood.
See, like 10th class problem, the moment the problem comes, I'll substitute one formula I own. It will take a lot of time, man. Learning only takes a lot of time. Once you
Yes,
become the master,
sir, your video.
Power cut, I guess.
Hello.
Yes, sir.
Yes, sir.
So, now understood this.
Yes, sir.
V1 is equal to V naught I minus U by
V naught I cap minus U by M plus M I cap. Do you agree with this? This is what you should get. Clear or not?
Clear, sir.
Yes, sir. Got it, sir.
Done this?
Yes,
Now,
sir.
this is the velocity of which buggy?
Rear buggy.
Rear
Rear
buggy.
buggy. Now we need front buggy, no?
No, sir. Yes, sir. Front buggy also needed, sir. Front buggy.
yes.
Come on. See here, now after the man comes over here,
The screen is not clear.
Yes.
blur, huh?
Yes, sir,
Not
you're
stuck,
right.
sir. Getting stuck, sir. Screen.
Yes, sir.
1 second. Now how is it?
Good,
Not clear,
good.
sir. Not clear.
See, now let this be the velocity finally after he jumps. Before the man jumps, what is his velocity? Remember, when the man is in A,
U plus V1 I cap.
in that case, this man has how much?
U
U
Plus
plus
plus,
V1
V.
item.
and this is having a velocity of V naught. Now
V
remember,
naught.
Yes, sir.
see always you should see just before, soon after, not long before, long after. Okay.
Yes, sir.
Yes, sir.
Now you can take this conserve moment as the initial momentum, then final momentum is, do you agree with this?
Yes, sir.
Then you have substitute this V1 also. Understood that? If we take this as common, what is V1 you got?
And V naught I cap minus mu by m. Yes, mu by m plus m. Yes.
You simplify this, you will be getting this result. First one to learn physics is have patience. Understood this?
Number 6. Sir.
Sir, after this, can you just show the previous page after this?
Hmm. Completed, man.
2
Yes, sir.
minutes. Sir,
Still.
we are saying after the man is in air, na sir. In that first case, PI.
Hmm. Hmm.
So if the man is in air, so we should write that velocity of rear buggy should be, it should not be V1 or V naught, sir. It should be V1, right?
I didn't get you anything what you're talking. Hmm?
So that should be V1, na, sir. I am asking that one, sir, because the the rear buggy man is
Here,
not
here,
present there, na,
here,
sir.
here, here. I took I took V1 only. You take a screenshot. Maybe
No,
you
sir, you
what
took
you
V1 only, sir. In that next page, sir, next page I am saying the PI.
you tell
It
this
should
one.
be M into U1 U plus V1 plus M V1, na, sir.
Which one?
Yeah, first one, sir, first equation. M into U
This.
plus V1 plus M V1. Yes, sir, that one. Because the man has moved in the air, na, sir. So that should be not V not, na, sir. It should be V1, right?
When is in air you have taken V1 now.
Yes, sir. Because the man is not present there, na, sir.
Hmm. So here also you should write this then. Followed this.
Yes, sir.
Sir, sir, excuse me, sir. Sir, I didn't understand this last, sir. Why we change this velocity from V naught to V1, sir? Can you
Pardon?
please? So this V naught to V1. Why we
No,
change it?
hopeless will Abrar. What I done is correct only. You are misguiding. This is
Yes,
second buggy. This
yes,
is
sir.
second buggy, man. This is what I have written is correct only.
Yes, sir. That's why I asked, sir.
This fellow confusion marshal confuse everybody.
Yes, sir. Sorry, sir.
Clear, sir.
Here the first buggy is not coming into picture now.
Yes, sir. Not coming to picture.
So we are conserving. Understood this?
Understood, sir.
Yes. Didn't so.
Come, sir.
One minute, sir.
Right. Got the answer now? Right.
Got the answer, sir.
See, you can see that certain forces, okay, are they act for a small duration of time, okay, but they cause definitely a great impact, okay. So, you can such forces are called. You learn that.
Ballistic force.
Understood this?
Understood, sir.
Screen mocking.
Hmm? Screen is not clear.
Is
No,
clear,
it is
sir.
clear. No, it is clear.
Clear.
Understood this?
Yes, sir. Understood.
Clear?
Clear, sir.
Now we cannot measure this impulsive force. Okay, only thing we can say is, Newton's law that it states that force, okay,
Yes, sir.
clear? Now this force varies with time.
Yes, sir.
Then only a rate of change is time now.
Yes, sir.
So you have dp, this is nothing but What is this actually?
Sir,
This is the measure of
impulse. Yes.
బట్టలతో సహా ఇవి కూడా పట్టుకొచ్చు దీన్ని కూడా అది తీగ వేసేసరికి బట్టలతో సహా అది కూడా పట్టుకొస్తుంది ఈ కింద వేసి అక్కడ తీసి
okay. This is called. This is what we call it as impulse.
Yes.
Understood this? Is it clear?
Yes.
Clear.
And this is nothing but change in momentum now.
Yes, sir.
Actually, you cannot measure the acceleration due to impulsive forces because we don't know the duration of the force. No.
Time is very short.
Shall I turn this?
So one minute, sir. So one doubt. After impulse, what is the difference? I bar or J bar?
J. Impulse generally J.
Okay, sir. Okay. Clear.
Shall I turn this?
One minute.
Completed?
5 minutes.
Exploding of a bomb is an impulse force.
Pardon?
Exploding of a bomb. Exploding bomb.
Hmm.
Is it an impulse force, sir?
Yes. Impulsive force only. Shall I turn this?
Yes. Completed.
If this force you can see it's a time varying force, no?
Yes, sir. Time very short.
Now what does this area give?
Sir, change in momentum.
Hmm?
Change in momentum.
Area is given by actually y dx, no? Here what is area?
F dt.
So this is nothing but impulse only, no?
Impulse.
Understood this?
Yes, sir.
Now we will take some time the same time interval. We will take the average force. Okay, this area and the above area are same. We have
Force versus time graph.
Great. So we can say that. So this is J can also be taken as average force into time duration. Agreed.
Agreed, sir. The time duration.
Finish this.
Yes, sir. Complete.
1 minute, sir.
Can you turn this?
Yes, sir, complete.
1 minute, sir.
Can you turn this?
Yes, sir. Completed.
Yeah. See here, bullets are going like this, no?
Yes, sir. Good.
Yes, sir.
So definitely there is a mass leaving the system, no?
Yes, sir. Mass is leaving the system.
So there will be a force here, no?
Yes, sir. Towards the system.
Remember?
Remember. dm by dt.
This is the thrust force, no?
Yes, sir. Just to force magnitude.
Agreed.
Agreed, sir.
So here mass is leaving the system now,
Yes, sir.
and the magnitude of that is the relative velocity mass
Minus,
is leaving now.
yes,
Do
sir.
you agree
Minus.
with this?
Agree, sir.
What is the velocity, man?
1 kilometer per second.
Negative sign indicates that mass is lost. How it is lost? 50 grams. How many bullets are there?
For sir, 20
20
bullets.
bullets.
20 bullets in 4 seconds. By 4.
Okay, in this direction, no?
Yes, sir.
Now to hold the gun, you should apply this force or not?
Yes, sir. Against the gun.
Hmm. How much is this? Do you agree with this?
Agree, sir. Agree, sir.
Please.
Shall I turn this?
One.
1 minute, sir.
Finish?
Yes, sir. Completed, sir.
1 minute.
1 minute.
Sir, completed, sir.
So 1 minute, sir.
Pardon?
1 minute, sir. That previous page.
Why, man? Why so much time you're taking?
Completed, sir. Completed.
Sir, completed, sir.
This is a pulley. Okay, so this is some mass that falls onto this. Okay,
Yes, sir.
this block mass is M. Another mass. Okay, so here
Excuse me, sir. Sir, one doubt, sir. Sir,
tell
from height h from it, and then after what is that word, sir?
sticks,
S.
sticks.
Oh,
Stick.
clear, sir. Clear, clear. Understood, sir.
Return this.
Yes, sir.
Hello.
Yes, sir. Completed.
Yes, sir.
See, be cautious here. This is the pan. There is a particle here, and the other one is nothing but a string. Okay,
Yes, sir. String.
we'll come to this first. Now this is falling now. Before falling, what is after it falls here? It has the pan velocity only, no? Agreed?
Yes, sir. Sticks to it. Yes, sir. Pan velocity. Yes.
Understood this? And
Understood.
Yes, sir.
clear not. This is for the
Yes.
particle. Any doubt
Yes.
is that till here?
No doubt, sir. Clear.
Actually,
No, sir.
here you can see on the particle there is a normal reaction, no?
Normal
And
reaction.
on the pan also there is a normal reaction, no?
Yes, sir. Normal reaction.
And also there is a tension on the pan.
Yes, sir.
String is there now.
Yes,
Any
sir.
doubt is there till here?
No doubt, sir. Clear.
That means this is an impulse only, no? It just falls. How much time it will take to come to rest?
Sometime.
The
Very less.
normal reaction is created in a short interval of time. Suddenly, due to that impulse, the momentum of the particle is changing or not? From here to here it is changing. That means this normal reaction is impulsive force or not?
Yes, sir. Impulsive
Followed
force.
what I am saying?
Yes, sir. It acts for a small
In
time.
a short time, particle has change in momentum. Agreed?
Yes.
Understood this? Therefore, I can say that in which direction this is actually upward equals change in momentum final
Minus.
minus initial. Do you agree with this?
Agree, sir.
Any doubt is there?
No doubt, sir. Yeah.
No doubt.
So I can simply write an equation. This is one equation. Any doubt is there till here?
No doubt, sir. Yeah.
Next. Shall I turn the page? See, as time passes, chapters will be very tough, I'm telling. Be cautious and put lot of work on that. Shall I turn this?
One, sir.
10 minutes.
I did not complete it. Just I wrote the momentum equation for that. Now for the pan, even for pan, see that suddenly the tension will change, no?
Sir, tension will be same now, sir.
No. See, when you are jerking, you pull a string suddenly, what will happen? It will break, no?
Yes, sir, it will break. Sometimes, yes, sir.
That means that is called impulsive tension. What is the tension called? Impulsive tension. For the pan, I can write like this. See, T minus N minus J. Initially, finally the pan is moving like this. Initially, the pan is at rest only, no? Remember?
At rest only, sir.
Yes, sir.
Any doubt is that till here?
No doubt, sir. Yeah.
Now for the block. For the block also there is an impulsive tension. Now suddenly it is falling now. So
Yes, sir.
tension causes an impulse. Now this goes up with a velocity v1 only, no?
Yes, sir, V1.
Do you agree with that?
Yes, sir, with velocity of fan, sir.
So this is it clear?
Clear,
Yes,
sir.
sir.
Now can you tell, shall I substitute these values here?
Yes, sir. 1 minute.
They are all short duration forces, no? So this I can write very simply integral
TdT minus integral NdT is equal to MV1.
T dt is what you have.
MV1 minus MV plus MV1 is equal to MV1. Yes, sir.
Agreed.
Agreed, sir.
So what is that you have here?
Sir, V1 is equal to V.
Hmm. See here, sorry. This is T minus N means plus J, no? Minus J, no? Hello.
It's a plus the upwards of tension is upward.
There is error here. So this is, I will write it as, understood this? So that is the reason why we are getting a different answer. Plus minus. Okay.
Yes, sir. Minus
Minus T1 place.
Yes.
Understood this?
Understood, sir.
So 3 mv1 is mv. What is v1? V by 3. It falls from a height h now.
Yes, sir.
So this is the speed immediately after the particle falls onto the pan. Is it clear? Any
Yes.
doubt is that it is very intricate concept actually. Suddenly you can see if you pull a tie one thread to, suppose you want to break the thread, what you will do? Suddenly you will apply force, remember?
We will pull.
Slowly if you apply, if it won't break, suddenly you pull it, it will break or not?
Pull
Catch
break.
the threads, ends of the threads with both hands, you will pull, apply force in opposite direction, very suddenly, no? Short time. It will break or not?
Pull break.
So that is an impulsive tension. Understood this?
Understood, sir.
Any doubt is there?
No, sir.
No doubt, sir. Yeah.
Okay, then complete this. We'll continue in the next class, okay?
So you are
Yes.
taking downwards as J cap now, sir.
Pardon?
You are taking downward direction as J cap now, sir. Here in this problem.
I am not, I am always taking downward minus j only. Upward j.
Yes.
Yes, sir.
Do it. You'll get the same thing. Hello?
Yes, sir.
Yes, sir.
Any doubt is there?
No, sir.
No doubt, sir.
Right then.
Sir, excuse me, sir. One doubt, sir.
Tell.
Sir, there is one type of balloon, sir. Means in if you put that in water, we can enter in that balloon and we can walk on water. Like that, one type of balloon is there, no, sir. In parks. Sir, my doubt is if if we are trying to move inside that balloon, we are applying internal force, no, sir.
Hmm.
But how it is moving, sir? With internal force, we cannot move, no, sir.
Which is moving, man? Tell.
Means this balloon is moving in water.
You tell my whole situation. You are inside the balloon, huh?
Yes, sir. I am inside that balloon, and that
Okay.
balloon is in water. But still, if I apply force, it is moving.
Which
But
is
I am
moving?
inside. Yes, sir. Sir?
Yes, man. There is negligible friction between the balloon and water, no?
Yes, sir.
Agreed?
Agreed, sir.
Clear or not?
Yeah, sir. But I didn't understand why we are moving, sir. Because of this self friction, or
When you're walking, normally you're applying some force
So,
on that body.
hello?
yes, sir. Yes, sir. Hearing, sir.
You are walking on the balloon. That means you are applying a backward force on the balloon, no?
Yes, sir.
Okay. Now that backward force, you are walking inside the balloon. That means on the inner part of the balloon of the lower portion, you are applying a force in backward direction, no?
Yes, sir. We are applying.
So here you are in the meeting, no? This is a balloon, no?
Yes, sir.
When you are walking, you apply a force like this on the inner surface.
Yes, sir.
Okay. Correct or not?
Follow,
So
sir.
that means the balloon wants to move like this. Balloon is moving or not now?
No, moving, sir. But it is internal force. That is my doubt, sir.
Which is internal force?
That means if we are inside, then we are
Internal
applying.
force is something which is acting on you, no?
No,
This
no,
is not
internal force is acting on the, you are calling it as an internal force, man. Do you agree with this?
Yes, sir. Agree.
As far as the, what is moving now, you tell?
Balloon is moving, sir.
For balloon, what is that force?
Sir, for balloon, it is external force.
No, that's what, it causes motion, no?
Okay, sir. Okay, sir.
Okay, anyhow, there is another aspect to discuss this. In fluid mechanics, there is one theorem called Bernoulli's theorem. Okay, then you will be knowing better. Now I just crudely I gave an explanation. Because you don't know Bernoulli's theorem.
Yes, sir. We don't know.
Right.
Clear, sir. Thank you, sir. Bye, sir.
Any more doubts?
No, no, sir.
No, sir.
Right.